Voice is not audible. Now voice is audible. If it is not audible, I'll reconnect. Say fast. Hey, is the voice audible now? Okay, I'm reconnecting. Is the voice audible? Yes or no? Okay, fine. Now listen. Everybody, start understanding the most important part. Today's session will be 2 hours. Sanjay, once I started the session late, miss, it will reach till late. But the session will be how many hours? 2 hours. So acid, bases and salt is a major important chapter. We are expecting nearly 6 to 7 marks questions from here. Okay. So basic informations of acid, bases and salt. Which sections are important today we are going to do. From which sections questions are coming, only we are going to highlight to that areas. Got it? So now the most important thing is acid, bases and salt. First we are going to talk about acid. In acid, what is the taste of acid? It is having sour taste. So we will just highlight the most important part and we will leave these sections. Now listen. Yes, it is having what taste? Got it? It is having sour taste. So now next part is, it is exactly, next is, it is converting blue litmus paper red. So this is the another important feature. Very good. And children, please start answering the questions as fast as possible. Means the more I am asking, I'll tell you not, I will not allow you in class in next time. Full time you are talking. I really wish that time should be. So what is the most important thing? It is turned red litmus paper blue or blue litmus paper red. Blue litmus paper red. How to remember this part? Here you remember acid turns blue litmus paper red. In alphabet, A after that what is coming? B. So acid turns blue litmus paper red. This is the most important part we have understood. Now it is like sour and taste. Some common fruits such as raw mango, grapes, orange and tamarind, it is having acids. They will never ask. He is the person, Arrhenius concept we are using. That is Arrhenius concept. Please understand. Many times the questions are coming and you people are misguided with the questions. The first important point here to remember is, when somebody will be asking you Arrhenius concept, when they will be asking, it is dissociation of acid as H plus ion. Dissociation of acid as H plus ion. H plus ion dissociation is done here. What dissociation is done here? H plus ion dissociation. So here, when acid is added in water, the dissociation will come. H plus ion will release. Understood or not? So the acid will break as positive and negative ions. Understood or not? So H plus ion will be released. How much fast H plus ion will be released? That much strong that acid is. So these are some concepts we must remember. Now here, acid and base, first we are going to understand this concept. Please understand this one. Just final revision we are doing. So touch and go policy we are going to apply. Now come on, check this one out. An acid when added in water will very fastly release H plus ion. Will very fastly release H plus ion. So if it is releasing total H plus ion as fast as possible, that means it is considered as a strong acid. But here, can you see here how many hydrogens are there? 4 hydrogens are there. But how many hydrogen it has released? Only one. Is it going to be a strong acid or a weak acid? Weak acid. The correct answer is it is going to be a weak acid. Understood? It is not going to be a strong acid. So on dissolution of water, acid will produce H plus ion. But this H plus ion with water, we'll remember this part, H plus ion. See, always remember H plus aqueous ion. So H plus aqueous means H3O plus. This is called as hydronium. What it is called as? Hydronium. What it is called as? Hydronium. Understood or not? So H3O plus ion is called as hydronium. H3O plus ion is called as what? Hydronium. I hope you people have understood what is the meaning of hydronium. Okay, H3O plus ion is called as hydrogen. For convenience, simplified H plus aqueous we are telling. What we are calling? H plus aqueous. So H plus aqueous or H3O plus both are called as hydronium. What is the name? Hydronium. Understood? So the acid properties of aqueous solution is exactly hydronium only. They'll never be asking this much, but we are going to now go for properties of acid. Today, touch and go policy we are applying. This video link will be positive before exam. We just have to see the video. You will get all the informations and important points. Understood or not? So now look here. So acid will be of how many types? Depending on strength. Strength means what, beta? Strong acid or weak acid. Strong acid means H plus ion will be released very, very fast. Weak acid means H plus ion will be released slow. So that is strong strength. Depending on sources. So acid will be divided into two sources, organic and inorganic. Organic and inorganic. Now you need to remember one thing, that inorganic acids are strong. Organic acids are weak. Remember this part. Inorganic acids. Where are the rest of the students? Everybody informed to join as fast as possible, or I'll cancel the class. Check you are live or not. Write your name. I'm seriously very angry. 25 days are left. Now, depending upon concentration, acid can be classified as concentrated acid or dilute acid. How many types are there? Two types. What are they? Concentrated acid and dilute acid. Very good. So now, depending upon basicity, what is the meaning of basicity? Monobasic or dibasic or tribasic. Understood? So here, this is very important. Dibasic acid, tribasic acid and monobasic acid, depending on molecular composition. So on molecular composition, this is called as oxy acid and hydra acid. So these are the most important part we must understand. So acids can be classified into how many types? Depending upon strength, depending upon source, depending upon concentration, depending on molecular composition, and depending on basicity. Understood? So these are the classifications we are. I will explain. Wait, everything I'm going to explain. So this is just touch and go. So everything I will explain with examples, so that it will become oxy acid and hydra acids. Two type will be there. What are they? Oxy acids and hydra acids. Now let's go to the next section, please. Depending on strength, how we are justifying the strength. This is the so much long story, but in short, we have to understand whenever acid strength is judged, how acid strength is judged, you understand one thing, how much fast an acid will release its all hydrogen ions. It is called as strong acid, and this state of release of H plus ion is called as degree of dissociation. What it is called as? Degree of dissociation. What it is called as? Degree of dissociation of what? Acids. It is called as what, beta? Degree of dissociation of acids. Understood? Now here, depending upon degree of dissociation, hydronium part, you check this one out. High degree of dissociation means highest or fast H plus ion will be released. So it will be having strong degree of dissociation. Now beta, understand one thing. Those acids which are exactly very fastly ionized, the acids which are very fastly ionized will have high degree of dissociation. Understood not? See, they will ionize completely. They will have highest degree of dissociation. Which and all? HCl, H2SO4, hydrochloric acid, sulfuric acid, nitric acid. The three acids will have high degree of dissociation. Everyone start typing and give me the answers. Okay? Weak acids, organic acids, degree of dissociation is very, very low. Can you tell me one inorganic acid which is a weak acid? Most of the inorganic acids are strong acids, but one acid is there which is inorganic and which is very, very weak acid, and it is used very much in industries, commercial industries. They are strong acids. Yes, Maha, only Mahalakshmi is correct. Rest of the nobody is correct. Please kindly say. It's citric acid is organic acid, idiot. The correct answer here is carbonic acid. Carbonic acid is added in soft drinks, cold drinks, so to that give fizziness. Understood not? And they are weak acids. Carbonic acids are considered as what? Weak acids. And carbonic acids are added to drink cold drinks. Understood not? Now, depending on source, source means what? Animal source, organic source are always considered as animal source, plant source. So they will be considered as organic. Inorganic will be mostly man made. Now we will go for the next part. Come on, check this one out. What and all are the source of organic? One time, last time we are revising before examination, and this video will be present in your group for a final layout. So please kindly check this one out. Red and what is the name? Formic acid. Tea, tannic acid. Gastric juice, tomato, sour milk, vinegar, tamarind, apple, orange, rancid butter, butyric acid, olive oil, fats, and urine, uric acid. So all these are exactly consisting of acid. So they will be considered as acids. Okay. So these are the different type of organic and inorganic organic acids. Now we are going to go for inorganic acids. What are the types of inorganic acids? Can we check inorganic acids types? Hydrochloric acid, H2HNO3, that is called as nitric acid, sulfuric acid, nitrous acid, and sulfurous acid. So they are different type of acids. I hope children you have understood. They are different type of acids. Now we are going to go. They show 100% of dissociation. Which acids? Note down quickly. Which acids are showing 100% of dissociation? Name, write down. Remember name. The inorganic acids which are strong acids, their degree of dissociation is highest. The inorganic acids which are strong acids, their degree of dissociation is highest. Degree of dissociation is highest. Understood? So they show 100% degree of dissociation. Okay. Now, beta, depending on concentration, come on, go for it, please. Nitric acid, nitrous acid, sulfuric acid, sulfurous acid, they'll all be considered as inorganic acids. But in that inorganic acids also, the some acids are there, their degree of dissociation is 100%. And they are hydrochloric acid, sulfuric acid, and nitric acids. Carbonic acid is also man-made acids, inorganic acid, but their degree of dissociation is weak. I hope you might have understood this one. Now, depending on concentration, what is the meaning of concentration here? Everybody listen very carefully. Concentration, many times they're asking this question because this year is a year of experiment. Say, listen, in MCQs and all, what they will be asking from you, how they are going to ask the question, that is very important. Now, if somebody will ask you what is the meaning of concentration, then what you are going to say? Dilute and concentration, what is the difference between them? Most of the time I'm asking this question. Now, let's see, in public I am asking what is concentrated or diluted acids. Yes, what is the difference between dilute or concentrated? See, concentration means the acid is not having water. Understood? It is dry. Dry means it is not having aqueous part. But what is the meaning of dilute and aqueous? How can we differentiate dilute and aqueous? See, and you only say, what is the basic difference between dilute and aqueous? All people are having confusion about it. Please first understand. If you laugh means I will slap you today. First, everybody focus into the part and listen carefully. Final piece examples and everything has to be very strong. Remember this one. When somebody will say diluted, diluted does not guarantee that always the solvent is water. Are you understanding? We can dilute a solute with another solution, solvent. Are you understanding? But aqueous means 100% water. So this is the difference between dilute and aqueous. So just understand today so that confusion will not be there. What is the meaning difference between dilute and aqueous? Aqueous means always water is solvent. Understood? Solute can be anything. Means you can dissolve anything inside it. So here, this is called as aqueous. But dilute means it may be water, may be other solvent. Other solvent. Other solvent means it can be alcohol or it can be any other thing. Understood? Tincture of iodine when we are talking about. So definitely we need to understand that when the solvent is other than water or water, it is considered as dilute. But when water is present as a solvent, it is called as aqueous. When water is present as a solvent, what it is called as? Aqueous. Remember this, don't confuse in examination. Did you understood the basic difference? Aqueous means dilute is guaranteeing water or not? Any maybe, but solvent can be water or cannot be water. But aqueous means understood or not? So always water. So definitely there are some things you have to understand and remember. Now look here, we'll go for next part. So that means what? Dilute means what? Here dilute means what? A small amount of acid is present in fixed amount of aqueous solution. So only I said dilution also result for water addition. Understood not? So here acid is added in water. Water cannot be added in acid because the moment water is added in acid, it will work as an explosive. Understood? Why? Because it will be highly exothermic and a high amount of H plus ion will be released in few fraction of seconds. So it will work as an explosive. Understood not? So because of that, always acid is added drop by drop and it is added with a glass stirrer in water beaker. The beaker full of water, 1 drop acid we are putting through a glass stirrer and then we are exactly shaking it and then the bottom part of the glass, what you call beaker, will become heat. Why? Because this is a concentration to dilution is a exothermic process. Not only acid, bases are also undergoing the same changes. I hope you might have understood. So not only acid, bases are also undergoing the same changes. I hope everybody understood. So now we will go for next one. Molecular composition. If somebody will be asking you molecular composition, what is the meaning of molecular composition? Molecular composition here means what molecules, what elements are present there. Can you check here? Oxy acid means oxygen will be present. So such type of acid in which oxygen is present is called as oxy acids. Note down this one is another important point. The acids in which oxygen is present is considered as oxy acids. See there they will play with words. Remember my word, they will play with word. Oxy acid, some very expensive word they will use there and you will get confused there. So now itself we will chapter by chapter dissect everything and come to know here. So what is the meaning of acids, oxyacids? The acid in which oxygen is present is considered as oxyacids. When then I'm expecting you and Porani offline, you are staying in Anupuram, you are not coming. So this is exactly considered as what? Oxyacid. So those acids in which oxygen is present is considered as oxyacids. Understood? So now here, when hydroacids means oxygen will not be there. Only hydrogen will be present. What will be present? Only hydrogen will be present. That will be exactly considered as what? Hydroacids. Hydroacids and oxyacids. What is the true difference between an acid having hydrogen is considered as hydroacids? See, always all the acids are hydroacids because all the acids will have hydrogen. But Lewis concept is there where hydrogen is not needed. Ions are there. That's a different concept. Then their hydroacids are checked. So mostly when we will be talking about hydroacids, the acids which are having hydrogen is considered as what? Hydroacids. The acids which are having oxygen is considered as oxyacids. Understood? So now we will go for depending on basicity. See, what is the meaning of basicity? I am there, you are there. Understood? I am giving you hydrogen. In return, you are giving me hydroxide, hydroxy. Hydrogen and hydroxy joining together will make water. Did you got my point? H2O. This is considered as basicity. What this is considered as? Basicity. What is the meaning of basicity? The meaning of basicity is given hydrogen and hydroxy will join. So if I will say I'm having 1 rupee, you will say, Auntie, can you give me 1 rupee? Correct now? I have once only, you are asking one now. If I will have 2, how many you will ask? 2. If I'm having 3, how many you will ask? 3. So that is called as monobasic, dibasic and tribasic. So if I am having only 1 hydrogen, what I am? Understood? Now you will be able to answer. If I am having only 1 hydrogen, if I am having 2 hydrogen, if I am having 3 hydrogen, that's it. Why basic word is used? Because I am going to meet with a base. Understood? Monobasic means I am going to meet with a base to make water. What a smile you are having. Fight you, I'll punch you. What a smile. Wait, I'll send your photo in group. This is the most expensive person smiling like anything. See, such a tremendous smile. See, Divya nicely. Slide photo. Means 2 minutes I will play with you. Means 3rd minute you will start playing with me. Correct na? See, beating is less skill. I did only one word. I just 2 minutes talked to you people and you started talking more. Now listen, hey, we'll go back to work, please. So what actually we discussed about? What actually we discussed? We talked about monobasic, dibasic, and tribasic. In monobasic, what we learned? 1 hydrogen is ready to be replaced. But di means, tri means, that's it. So here, please check this part out depending on basicity. Basicity of an acid means that number of replaceable hydrogen atoms present in 1 molecule of acid that can form hydronium ion. So how many are there? We are going to check this one out. Come on, see. Monobasic means how many replaceable hydrogens are there? 1. Dibasic means how many are there? 2. Tribasic means how many there? 3. So that's called as monobasic, dibasic and tribasic. Understood? Now we are going to prepare acid. So till here, this is the first time we have finished acid, bases and salt in so fast pace. Yes, mono, di, tri. Tetra means Mostly acid will not do that. They are very disciplined. Okay. Are you ready? Octa. Octa will not do. Now look here. Shall we go for preparation of acid? Hey, now get serious, please. From here, one question will come. Till now, we were doing just warming up exercise. From here, we have to be, yeah, because most of the questions will not come from there. What we learned, we just understand degree of dissociation. From degree of dissociation, hardly one question. If they will have mercy on you, they will ask. Understood? They'll not ask, what is the taste of acid? They'll not be asking like that, please. Are you ready? 100%? Okay. So now listen. Why you are planning to get killed by me? Now listen. First is we can prepare acid with the help of combination reaction. Understood or not? So this is called as synthesis. I want all of you to note down it very carefully, because when we will start solving question answers, tomorrow also 2 to 3 hour class will be there. Tomorrow morning 6 o'clock class is there. We will be continuing acid, bases and salt. Huh? Yeah, then we will study 2 to 3 hours. Huh? But recorded will be there, na? That recorded you have to. Now listen everyone. Shall we start our work, please? It's 2 minutes I spoke something. Miss third minute you will start dancing. Correct now? Now come on. We will talk about direct combination. See, hydrogen and bromine. So here what is needed? So generally hydrogen, bromide, hydrochloric acid, they are considered as acids. So here combination reaction is needed. So here generally binary acids are made. What acids are made? Binary acids. What is the meaning of binary acids? The acid which will have hydrogen with halogen or any other element. So such acids are considered as binary acids. Understood? So here very good, Sanjay. Here it is exactly case of binary acid. So see, hydrogen will combine with bromine. What it is making? HBr. So this is exactly considered as binary acid. HCl, hydrochloric acid. It is what type of acid? Binary acid. Again it is binary. Now double displacement is a very important part. Please kindly remember this one. Acid and base react. Whenever acid and base will add, it will always form salt and water. Now here, one acid can generate another acid. This concept. So here, in this part, this is called as double displacement. This part is called as double displacement. Usually, many times we are seeing that in double displacement, salts are formed. Correct, na? Salt, but highly reactive substances are displacing the less reactive substances. So that concept keeping in mind, and here reaction proceeding, you please understand what is the case here for double displacement. This is the 30th minute of the class. Please check double displacement. Note down. Temperature is very important for both the reactions. Now we are going to be very precise. Remember this part. Double salt formation here. You check it is not double salt, please. This is exactly salt and this is acid. Understood? So please kindly remember, when salt and acid react below how much temperature? 200 degrees Celsius. What they are making? Sodium hydrogen sulfate, which is aqueous and it is salt, and another acid HCl is formed. Come on, note down this. NaNO3, nitric acid, sodium nitrate react with sulfuric acid, again salt and acid. And it is making sodium sulfate and nitric acid. Nitric acid is a strong acid. Remember this part, please note down as fast as possible. These two reactions should be there in your box, always. Note down, keep it. This video will be not there in YouTube channel, but it will be there in your group. Understood? The moment this video will be over, miss, it will become private. They can't download it, they can't do it anything, but only our students will be having access of it. Okay? So please kindly remember, before exams, we can see this video and we can study as fast as possible. So now come on, go for it. Can you write down the equation fast? What is the equation here? For temperature here. What is the temperature here? Below 200 degrees Celsius. NaNO3, NaNO3, H2SO4. Above 200 degree Celsius. So this is exactly the case, above 200 degree Celsius. So this is the most important part. Now we will talk about preparation in that direct combination. This section already 2 times, I think it is the okay. Now reaction with sodium chloride. This is a very important reaction. See, most of the time they are not going to ask. This is exactly not going to be asked, but one time I have told you how it is exactly done. So reaction sodium chloride is a very it is exactly laboratory one most important reactions. Please kindly check this one out. When sodium chloride will react with sulfuric acid. So procedure is given. This PDF will be one time when you will be reading, it will be available. Understood or not? Now we will go for the next one. Generally, they will not ask. In NCERT book, making is not there. Is making there? No. So you will not do making. Just remember this one. Now look here. By the reaction of acidic oxide. So now look here. Sulfur trioxide when react with water, it will make what? Sulfuric acid. And this is exactly one of the example of acid rain. From factory, what in all residues are exactly coming? You remember? Do you remember from factory? Sulfur trioxide is coming. From vehicle, carbon dioxide is coming. When this will add with water vapor of atmosphere, what they will make? And if this will add with water, it will become, when nitrogen dioxide will add, it will make nitric acid. Understood not? NO2 will join, it will make nitric acid. CO2 will join, it will make, SO3 will join, what it will make? Sulfuric acid. Remember, NO2 also write down. NO2 is not air. So NO2 also remember that these will be joining together and they will be, so they are major cause of acid rain. Understood not? So monuments, marbles, they are getting destroyed because of these type of chemicals getting added with these type of gases, getting added with water and doing what type of rain? Acid rain. Understood? So sulfur trioxide is gases, carbon dioxide is gas, and nitrogen dioxide is gas. So when they will be added with water molecules of atmosphere, what they will do? They will do acid formation, and the rain will be considered as acid rains. Now this much is not needed, this part is not needed, they'll not build this much. Now physical properties. We will be exactly going towards the physical properties here. Now what is exactly physical property? One more time revision, check this one beta. You remember this part very nicely. Some acids are solid, some acids are liquid, and some acids are gases. So definitely we will check one time. Can we check taste? Acid have what type of taste? Sour taste. Mineral acids like H2SO4, nitric acid, they are corrosive in nature and they will be soapy to touch. They should not be tasted. Understood? Not soapy, I'm saying, sorry. They should not be tasted because acids are always corrosive in nature. Understood? Not? Now physical state. So in physical state, we are going to talk about what in all are the state: boric acid, oxalic acid, tartaric acid, citric acid, phosphoric acid, acetic acid, formic acid, carbonic acid. So they look here, but till phosphoric acid it is solid. Now acetic, formic, carbonic, hydrochloric, nitric, sulfuric and sulfurous, all are exactly liquid acids. HCl is exactly gases, but we are diluting it. So it will become what type acid? Liquid. Understood? So acid can be present in two states. What are they? Solid and gases. Tartaric acid, oxalic acid, boric acid, hydrochloric acid, sulfuric acid, carbonic acid, sulfurous acid. Understood? Formic acid, liquid. So these are some very important points to be remembered. How is the session today? Learning? So this PDF will be available in your group. Now we are going to go for, because now we have done the acid preparation. We can prepare acid. See, please remember acid preparation. One is double displacement, another one is combination. One more was there, when gases are added with water. They are also making acids. Understood or not? One laboratory preparation method was also there. Yes, but they will give like that type of situations only for case studies. Understood? They'll give you all direct informations. Now, beta, we will talk about indicators. So there are two different type of indicators. One is exactly natural indicator. Another one is man-made indicators. Natural indicators and man-made indicators. Understood? So natural indicators and man-made indicators. So now indicators are complex substances that acquire different color in acidic or basic medium. So now what we are going to do, check litmus, methyl orange and phenolphthalein. What are the three important parts? Litmus, methyl orange and phenolphthalein. So phenolphthalein now, phenolphthalein. What we are calling it as phenolphthalein. Understood or not? What happened, Mukundan? Focus in now studies. So litmus solution will turn blue to red. Methyl orange, phenolphthalein. Understood? Note down one time, please. If somebody will ask you, they will have confusion, then please remember one thing, hydrochloric acid is gas actually. But when we are converting it into liquid, it will become hydrochloric. Hmm. Liquid. Are you all happy? This type of revision is okay? Huh? Now look at it. They change color to of indicator. How they are changing? Methyl orange. Phenolphthalein. Very good. Why acids? So these are some chemical properties now. Acids are what? Good electrolyte. Why? Because the moment they are added in water, they will dissociate. So once they are added in water, they are getting dissociated. Next is all acids when dissolved in water dissociate to form ions. So therefore they can conduct electricity. Next, acids have corrosive nature. What it is exactly called as, beta? Corrosive nature. Understood? Corrosive. So they cannot be, they can corrode even metals also. Colorless video is there. So now what is phenolphthalein? I think we know about this solution. Methyl orange in this set it is not colorful. Now we are going to talk about chemical properties. Understood or not? Now we are going to talk about the chemical properties. Remember, chemical property is a very important section. And I want, yes, chemical properties. Indicator part done na? In indicator, how acid is responding? Yes. With methyl orange? Orange to? With phenolphthalein? Litmus paper? Very good. So these are exactly the most important part. Now we'll go for the next one. Please kindly check this one out. Now look here. Chemical properties. Reaction with active metal. Elaboration, are you all right? Now please check this one out. Reaction with active metals. Acid do react with metals. Now what type of reaction? When acid will react with metal, it is what type of reaction? Exothermic reaction, I'm not asking. I'm asking one simple thing. As before me, you people are telling, but I'm just asking one simple question. When an acid is reacting with metal, what type of reaction it is? When acid are reacting with, listen, Beta, this is called as neutralization reaction here. Acid and base. Metal is basic oxide. They are basic in nature. Metals are basic in nature. And acids plus base, it will make salt and water and hydrogen. So salt and hydrogen. So here acid and metal is there. Neutralization. Everyone understand this one. So it is coming as neutralization. So for simple part, I am telling you to remember all the metals are basic. All the metals are basic and metal oxides are basic oxides. Note down, all the metals are basic and metal oxides are basic oxides. All the metals are basic and basic oxides, what are they? All the metal oxides are basic oxides. All the metal oxides are basic oxides. Did you understood? So metals are what, beta? Metals are acidic or basic? The metals are basic. And all the metal oxides are basic oxides. This is understandable or not? Tough or easy? Very good. So now we are going to go for reaction. Please see here, acid and metal, it is exactly, but here one situation is there. This situation I'm underlining. You remember this one or note down this one. See here, what part actually it is there. Reaction with active metal. Reaction with active metals. Here what they are telling, acid evolve hydrogen gas when they react with active metals. Understood? Strong metals. Correct? So now let's talk about the acids which is used. We are not using nitric acid. Note down. We are not using nitric acid in this type reactions. Why we are not using nitric acids? We are using mostly, no, there is a reason behind. Note down, nitric acid is a strong oxidizing agent. Note down. What they are? Oxidizing agent, due to which they release H2 gets converted into water molecule. Understood not? So very dilute nitric acid is used. If you want hydrogen gas, means how much dilute nitric acid is used? Very dilute nitric acid. Means in 99% of water, how much percent of nitric acid will be there? 1%. Yes, Sanjay. This part you must remember, Sanjay, that what is exactly the part, beta? Strong oxidizing agent. What are they? Strong oxidizing agent. This word you remember with nitric acid. Any metal react with nitric acid, they will strongly oxidize. And when they will strongly oxidize, what they will release, beta? Water. But we want hydrogen gas. For that, what we are going to do? 99% of water and 1% of, very good, 1% of HNO3. That is, yes. I hope everybody understood. Come on, say yes. Thank you for liking the session. All people can at least say thumbs up. Yes. What is the reason behind it? That's that oxidizing agent. The reason behind is the oxidizing agent, and that's what I have discussed. The reason behind is what? Oxidizing agent. Everybody understood? Now magnesium will react with HCl. What it is making? Iron, zinc. This is one very important reaction with metals. Metals are what, beta? And metal oxides are? Non-metals are? Non-metal oxides? Very good. Very good, Sanjay. So now look here, children. This is what is needed in this state. This state means you people have to be very carefully reading all that part. Understood or not? Now look here, reaction with base. First one we learned is metal. Second one we learned is base. So when we are doing with base, what is exactly base plus acid? What is this reaction is called as? Neutralization reaction. And with a neutralization reaction, what is released? Water is released. A neutralization reaction, what is released? Water is released. Salt and water. Understood or not? Salt and water. This state is called as salt and water. This is what type of reaction? Neutralization reaction. I hope till here everything is clear. I hope till here everything is clear, children. Two reactions we talked about. Neutralization. Acid plus base will give salt and water. Metal reaction with acid, salt and hydrogen. Which acid is creating problem? Nitric acid. How much we want? It should be very diluted, means only 1%. Then it will release what? Other 1% means hydrogen. Remaining means if it will be more than 1%, it will release water. If it is less than 1%, it will release hydrogen. That's the most important thing. I hope this is exactly most important. Note down this PDF. Now reaction with metal oxide. So what they are going to make? Reaction with metal oxide, definitely water molecule. This is again what? This is a type of neutralization reaction. Note down, this is exactly metal oxides are basic in nature. Metal oxides are basic in nature. So that is basic in nature. And this metal oxide base plus acid is salt and water. So here carbon calcium oxide base. What they are making? Copper oxide, sulfuric acid, salt and water, copper oxide, HCl. And what is the color for copper, beta? Remember, color for copper, blue, green. What is the color for copper chloride? Copper chloride is blue, green. Bg, color copper chloride is blue, green. Hey, many times color they are asking. Many times in the sample set, we have seen they are asking color. Carbons, FeSO4, CuSO4, CuCl2, their name. Now, right now, in your notebook, you note down what is the color of CuCl2. Now you are remembering. Afterwards, don't forget. CuCl2, what is the color? Blue, green. Blue, green color. Metal oxide react with acid to form salt and water. So it will also be considered as what type of reaction? Neutralization reaction. Now reaction with metal sulfides and metal bisulfides. Please, you do this extra fitting. Trust me. Understood? Metal sulfide and metal bisulfide. Please understand this one. Metal sulfide like CaSO4, calcium sulfate. When calcium sulfate will be there, what it is making? Calcium chloride. Here one thing is released, that is sulfur dioxide. Please kindly write this reaction. Here also salt and water will be there, but one gas will be released, and that is sulfur dioxide. Children, how is the session now? Is the session okay? Tomorrow also I am planning to keep session. First I will go Tripal Kundram for giving maths revision. After that I'll return back and I will give science revision. Understood? Yes, but when they are making oxide, the color will change. Okay. Did you understood? Calcium sulfate. What they are making? Sodium bisulfate. Sodium chloride, which is a salt. Understood? So this is the reaction with metal sulfide and metal bisulfide. What is the byproduct? Salt plus hydrogen sulfide. This much is not needed. Reaction with chloride, they are never asking. Reaction with nitrate also, they are never asking, but nitric acid is released. What is released here is nitric acid. What is released here, beta? Nitric acid. And here, when they will react with chlorine, what will be released? Hydrochloric acid. As a gas form, it is released. I hope till here you have understood it nicely. Now we are going to talk about uses of acid. This is most important part, uses of acid. Many times in MCQs, they will be using, in MCQs or any other formats, they may be asking citric acid, preservative. Pickles and all we are preserving. Pickles and all we are preserving. Citric acid. Now ascorbic acid as flavoring. So citric acid is also used for flavor and it is for preservation. Ascorbic acid, vitamin C, treatment of scurvy. So only orange, always the doctors are preferring that. Okay, you take orange. Why they are telling to take orange? Because it is exactly releasing you from scurvy. Teeth defect. Scurvy is what? Teeth defective. Teeth disorders, tooth disorders are coming. That is exactly coming as scurvy. Okay. So now look here. Acetic acid. So when somebody will be talking about acetic acid, vinegar, understood, preservative. It is also added to pickles to make it sour. So added to pickle to make it sour. Next is tartaric acid. What is the use of tartaric acid? A component of baking powder. Note down. So that was tartaric acid. It will exactly, baking soda will get converted into baking powder in addition of tartaric acid. So if tartaric acid is added, it will convert, say, baking soda into baking powder. Next, oxalic acid, an ink stain remover. Now comes inorganic. First we talked about all weak acid. Now we are talking about all strong acid. Hydrochloric acid, gastric juices. Next, toilet cleaner, manufacturing of polyvinyl chloride. Nitric acid, rainwater forms present in rainwater. It is exactly for soil. Understood? Which are then used for plant to obtain nitrogen. It is exactly useful. It is exactly useful. Remember this one, beta. Nitric acid is actually useful. It is manufacturing of fertilizer. Nitric acid is used for manufacturing of fertilizer. Nitric acid is used in making explosive like TNT and dynamite, sorry, to explode the mountain and stones. Understood or not? So that is exactly used. Next part is sulfuric acid in manufacturing of fertilizers, paints and pigments, in artificial fiber also. Phosphoric in manufacturing of, in batteries it is used, sulfuric acid. I thought I forgot this. No, it is exactly dry cell, Daniel cells, different type of cells are there. Their storage means what is used here is sulfuric acid. Next one, beta, phosphoric acid in fertilizers and detergent. Because you know na NPK is there, nitrogen, phosphorus and potassium. So they are the major nutrient for the plants. So definitely they phosphoric acid means fertilizer. Boric acid, glass, glaze, enables. Which one understanding a bit of widely used in detergent as food preservative also. Carbonic acid, flavoring drink as, and here benzoic acid, preservation of food in perfume and medicines. I hope you might have understood till here. How was the session? Huh? Nice. We finished acids. No, this is one set over. In 10 minutes, you will be able to reach home. Can I start, restart with bases, or now only can I start? Okay. One time you people are not asking. Vishwa can go. Hey, bye, ma'am. I didn't told it. I'm going to stop it. Please. Shall we continue for more next basis salt? Basis section? I'll make second video as basis. Okay, can I give some break or what you people are wanting? Tell.